Let's look at another molecule, ammonia, NH3. Now, nitrogen is a nonmetal. Hydrogen, remember, looks like it's on the metal side of the periodic table, but actually hydrogen is classified as a nonmetal. So this will also be two nonmetals. So we still have covalent bonding. The most symmetrical way to arrange these atoms is put the nitrogen in the middle and the three hydrogens on the outside. Each hydrogen has one valence electron and the nitrogen has 5, so we have a total of 8 valence electrons to put into this picture. Step number 1 is connect the central atom to the terminal atom with 2 electrons. And instead of drawing 2 dots and then having to rewrite the picture, once you know that a single line is 2 electrons, we can just go ahead and start with a single line connecting the central nitrogen to the 3 terminal hydrogens. The next step would be to satisfy the terminal atoms, the hydrogen. And remember, hydrogen, to reach the closest noble gas, which is helium, hydrogen only needs one more electron. It doesn't need a total of 8 electrons around it. It's very important to remember hydrogen can reach group 18 with only 2 electrons total. So the octet rule is satisfied for each one of these hydrogens because we've reached the group 18 stability of helium. Remember, helium only has 2 valence electrons. So hydrogen will always look like this in a correct Lewis structure. It'll always have a single bond to a hydrogen. It'll never have any lone pair electrons. It'll never have a double bond. It'll never have a triple bond. So all 3 hydrogens are satisfied. The nitrogen, however, is trying to get to group 18. It needs 8 electrons, and right now it only has 6. So we can give it 2 more, and that matches all 8 electrons that we have to use up in this picture. So this is the correct Lewis structure of ammonia. Water would be similar to ammonia. The difference is oxygen would be in the center instead of nitrogen. Each hydrogen has 1 valence electron, and the oxygen found in group 16 is going to have 6 more. So this picture will also have 8 electrons. Takes 2 to connect terminal to central oxygen, and that uses up our first 4 electrons. The oxygen would be satisfied with 2 more pairs of electrons. So that's a total of 4 more electrons to reach the octet rule. And we've used up all 8 electrons, and we've satisfied both the central and the terminal atoms. Hydroxide. This is our first one with a charge to it, so it's an anion. We have to remember to add 1 electron to our total. When you only have 2 elements, it doesn't matter which one you write first, which one you write second. The number of valence electrons, oxygen contributes 6, hydrogen contributes 1, and then the negative charge means we have to add 1 more. So this also has 8 valence electrons. When you only have 2 atoms, which one you call central and which one you call terminal really doesn't matter so much. So we connect the 2 atoms together with 2 electrons. Notice the hydrogen is already satisfied with its 2. The oxygen needs 6 more, and we happen to have 6 more. So that would make 3 lone pairs of electrons around the oxygen, and that would satisfy the octet rule. Now, some people take an extra step, and when you have an ion, they'll write square brackets around the whole thing and then put a superscript for the charge.